Hello. Continuing from where I left off. It's around here. 10. Of the fruits. Now we come to the fruits. We will soon realize that these have the same origin as the other parts and are subject to the same laws. Here, we are actually speaking of the capsules formed by nature to enclose the so-called covered seeds, or more precisely, to develop a small or large number of seeds by fructification within these capsules. It will not require much to show that these containers may also be explained through the nature and structure of the parts discussed earlier. 75. Retrogressive metamorphosis again makes us aware of this natural law. Thus, for example, in the pinks, these flowers known and loved for their irregularity, we often find that the seed capsules are changed back into leaves resembling those in the calyx, and the styles are accordingly shortened. There are even pinks in which the fruit capsule is completely transformed into a true calyx. The divisions at the tips of the calyx still bear delicate remnants of the styles and stigmas. A more or less full corolla develops, instead of seeds, from the very center of this second calyx. Image 37. Pinks. Dianthus. Dianthus. Displaying retrogressive metamorphosis. Image 38. Leaves of big leaf. Linden. Tilia platyphylos. Showing midrib stalks. 37 and 38. '76. Even in regular and constant formations, nature has many ways of revealing the fruitlessness hidden in a leaf. Even in regular and constant formations, nature has many ways of revealing the fruitlessness. Nope. Let's try this again. Even in regular and constant formations, nature has many ways of revealing the fruitfulness hidden in a leaf. Thus, an altered but still recognizable leaf of the European linden produces a small stalk from its midrib and grows a complete flower and fruit on this stalk. The disposition of blossoms and fruits on leaves of Husks is even more remarkable. Image 39. Image 39. Butcher's broom. Husks oculatus with fruit. Ruscus. Aculeatus. Butcher's broom with fruit. Even in regular and constant formations, nature has many ways of revealing the fruitfulness hidden in a leaf. Thus, an altered but still recognizable leaf of the European linden produces a small stalk from its midrib and grows a complete flower and fruit on this stalk. The disposition of blossoms and fruits on the leaves of the ruscus is even more remarkable. Image 39. Image 77. In the ferns, we see still stronger, we might even say enormous, evidence of the sheer fruitfulness inherent in the stem leaves. These develop and scatter innumerable seeds, or rather germs, through an inner impulse, and probably without any well defined action by two genders. Here, the fruitfulness of a single leaf rivals that of a wide spreading plant, or even a large tree with its many branches. Image 40. Frond of autumn fern, Triopteris, Arinthosora, Arethrosora, 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 Triopteris Arethrosora. Frond of autumn fern, Triopteris Arethrosora. I like that. Triopteris Arethrosora. That's this right here. Triopteris Arethrosora. And it says, frond of autumn fern displaying red spore cases. '78. With these observations in mind, we will not fail to recognize the leaf form in seed vessels, regardless of their manifold formations, their particular purpose and context. Thus, for example, the pod may be viewed as a single, folded leaf with its edges grown together, husks, as consisting of leaves grown more over one another, and compound capsules may be understood as several leaves, united round a central point, with their inner sides open toward one another, and their edges joined. Images 41 and 42. Let's check out those images. It's image 41. It says seed pods of oriental poppy, Papaver orientale. Papaver orientale. Image 42. Seed pods of iris with outer covering partially removed to reveal seeds. Iris. With these observations in mind, we will not fail to recognize the leaf form in seed vessels, regardless of their manifold formations, their particular purpose and context. Thus, for example, the pod may be viewed as a single, folded leaf with its edges grown together, husks, as consisting of leaves grown more over one another, and compound capsules may be understood as several leaves united round a central point, with their inner sides open toward one another and their edges joined. Images 41 and 42. We can see this for ourselves when these compound capsules burst apart after maturation, for each part will then present itself as an open pod or husk. We may also observe a similar process taking place regularly in different species of the same genus, The fruit capsules of the Nigella orientalis, for instance, are partially merged pods grouped around an axis, but in Nigella damascena they are fully merged. Figures 14 and 15. Figures 14 and 15. In the 14, it says fruit capsules of Nigella orientalis. In the 15, it says fruit capsules of Nigella damascena. With these observations in mind, we will not fail to recognize the leaf form in seed vessels, regardless of their manifold formations, their particular purpose and context. Thus, for example, the pod may be viewed as a single folded leaf with its edges grown together, husks as consisting of leaves grown more over one another, and compound capsules may be understood as several leaves united around a central point, with their inner sides open toward one another and their edges joined. Images 41 and 42. We can see this for ourselves when these compound capsules burst apart after maturation, for each part will then present itself as an open pod or husk. We may also observe a similar process taking place regularly in different species of the same genus. The fruit capsules of Nigella orientalis, for instance, are partially merged pods grouped around an axis, but in Nigella damascena they are fully merged. Figures 14 and 15. 79. Nature masks the resemblance to the leaf mainly by forming soft, juicy seed vessels or hard, woody ones. But this similarity will not escape our attention if we know how to follow it carefully through all its transitions. Here we will have to be content with having given a description of the general concept, along with several examples of nature's consistent behavior. The great variety in seed capsules will provide material for a great many other observations in the future. 80. The relationship between the seed capsules and the previous parts also appears in the stigma, situated right on top of the seed capsule and inseparably joined to it. We have already demonstrated the relationship of the stigma to the leaf form, and here we may note it again. In double poppies, we find that the stigmas of the seed capsules are changed into delicate, colored leaflets that look exactly like petals. 81. The last and most pronounced expansion in the growth of the plant appears in the fruit. This expansion is often very great, even enormous, in inner force as well as outer form, since it usually occurs after fertilization. It seems likely that as the developing seed draws juices from the entire plant for its growth, the flow of these juices is directed into the seed capsule. The vessels of the seed capsule are thereby nourished and expanded, often becoming extremely gorged and swollen. It can be inferred from our earlier discussion that purer gases play a part in this, an inference supported by the discovery that the distended pods of Holutea contain a pure gas. Colutea contain a pure gas. Figure 16. Hulls of Clutea arborescens, Clutea arborescens, and Clutea herbaceae, showing their leaf-like character. Arborescens and herbaceae. Chapter 11. Of the coverings lying next to the seed. 82. By way of contrast, the seed is in the most extreme state of contraction and inner development. In various plants, we can observe that the seed transforms leaves into an outer covering, adapts them more or less to its shape, and often has the power to annex them fully, completely changing their form. We saw above that many seeds can develop in and from a single leaf. Hence, it will come as no surprise to find a single embryo clothed in a leaf covering. We saw above that many seeds can develop in and from a single leaf. Hence, it will come as no surprise to find a single embryo clothed in a leaf covering. 83. We can see the traces of such incompletely adapted leaf forms in many winged seeds. For example, the maple, the elm, the ash, and the birch. Images 43 through 46. Image 43. Image 44. The image 43, leaves and winged seeds of Japanese maple, Acer palmatum. Image 44, leaves and seeds of Camperdown elm, Ulmus glabra, Ulmus glabra. Image 45, image 46. Image 45, leaves and seeds of green ash, Fraxinus pennsylvanica. Image 46, leaves and seed-bearing catkins of paper birch, Betula papyrifera. We can see the traces of such incompletely adapted leaf forms in many winged seeds. For example, the maple, the elm, the ash, and the birch. Images 43 through 46. The Calendula's three distinct rings of differently formed seeds offer a remarkable example of how the embryo pulls broad coverings together, gradually adapting them to its shape. Figure 17. Figure 17. Seeds of Calendula. We can see the traces of such incompletely adapted leaf forms in many winged seeds. For example, the maple, the elm, the ash, and the birch. Images 43 through 46. The calendula's three distinct rings of differently formed seeds offer a remarkable example of how the embryo pulls broad coverings together, gradually adapting them to its shape. Figure 17. The outer ring is still related to the petals in form, except that a rudimentary seed swells the rib, causing a fold in the leaf. A small membrane also runs lengthwise along the inside of the crease, dividing the leaf in two. The next ring shows further changes. The broad form of the leaf has entirely disappeared, along with the membrane, but its shape is somewhat less elongated, while the rudimentary seed on the back has become more visible, and the small raised spots on the seed have grown more distinct. These two rows appear to be either unfructified or only partially fructified. They are followed by a third row of seeds in their true form, strongly curved and with a tightly tilted involucra that is fully developed in all its ridges and raised portions. Here we again see a powerful contraction of broad, leaf like parts, a contraction produced by the inner power of the seed, just as we earlier saw the flower leaf contracted by the power of the anthers. Chapter 12. Review and Transition. 84. Thus, we have sought to follow as carefully as possible in the footsteps of nature. We have accompanied the outer form of the plant through all its transformations, from the seed to the formation of a new seed. We have investigated the outer expression of the forces by which the plant gradually transforms one and the same organ, but without any pretense of uncovering the basic impulses behind the natural phenomena, so as not to lose the thread that guides us. We have limited our discussion entirely to annual plants. We have noted only the transformation of the leaves accompanying the nodes, and have derived all the forms from them. But to lend our discussion the required thoroughness, we must now speak of the eyes hidden beneath each leaf. Under certain circumstances, these develop, and under others, they seem to disappear entirely. Chapter 13. Of the eyes and their development. 85. Nature has given each node the power to produce one or more eyes. This process takes place near its companion leaves, which seem to prepare the way for the formation and growth of the eyes and help in their production. Figure 18. Diagrammic sketch of young Dictyonius plant, Dicotyledonous, Dicotyledonous plant. White equal parts already developed, hatched equal those still in process of extension and growth, black equal youngest parts, and axils of cotyledons and leaves proper. The eyes or buds can be seen. Of this, it says diagrammic sketch of young dicotyledonous plant. White is the parts already developed. Hatched is those still in process of extension and growth. Black, the youngest parts. Then the axils of cotyledons and leaves proper. The eyes or buds can be seen. '86. The primary, simple, slow process of plant reproduction is based on successive development of one node from the other and the growth of an eye close to it. '87. We know that such an eye is similar to the ripe seed in its effect. In fact, we can often recognize the whole shape of the potential plant more easily in the eye than in the seed. '88. Although the root point is hard to find in the eye, it is just as much there as in the seed and will develop quickly and easily, especially in the presence of moisture. Under that, there is an image 47. Image 47. Potato. Solanum tuberosum. Solanum tuberosum, with sprouts growing from eyes. '89. The eye needs no cotyledon because it is connected to the fully developed parent plant and receives adequate nourishment as long as the connection remains. Once separated, it will draw nourishment from the plant to which it is grafted or from the roots developed as soon as a branch is planted in the earth. '90. The eye consists of more or less developed nodes and leaves that have the task of enhancing the future growth of the plant. Thus, the side branches growing from the nodes of the plant may be considered separate small plants placed on the parent in the same way that the parent is attached to the earth. '91. The two have often been compared and contrasted, most recently in such an intelligent and exact way that we will simply refer to it here with our unqualified admiration. Der fructibus et seminibus plantarum, Chapter 1. fossil reference. 92. We will say only the following on this point. Nature makes a clear distinction between eyes and seeds in plants with a highly differentiated structure. But if we descend to plants with a less differentiated structure, the two become indistinguishable, even for the sharpest observer. There are seeds that are clearly seeds, and Gemmae that are clearly Gemmae. But it takes an act of reason rather than observation to find the connection between the seeds, which are actually fertilized and separated from the parent plant by the reproductive process, and the Gemmae, which simply grow out of the plant and detach without apparent cause. 93. With this in mind, we may conclude that the seeds are closely related to the eyes and Gemmae, although they differ from the eyes in being enclosed and from the Gemmae in having a perceptible cause for their formation and separation.